Now that we've been talking about the fundamental theorem of calculus, we're going to look at some popular AP problems that have to deal with the fundamental theorem of calculus. At the end of this lesson, you'll be able to use the fundamental theorem of calculus to solve problems. Right, the first one, it's to find f of 4 if the integral from 1 to 4 of f prime of x is equal to 7.5, and we are given that f of 1 is equal to 0.5. So far, right now, this probably doesn't really look like it makes much sense, so let's just kind of dig it apart a little bit. Let's take a look at this left side of the equation. Usually if we're given something and it's asking us to find an integral from 1 to 4, we generally should hopefully think of the fundamental theorem of calculus, where we actually take the antiderivative of this part, and then we evaluate it at 4, we evaluate it at 1, and then we work it out. So first thing that I'm going to do is, we're used to a function being here, but we'll just go with f prime being there. When I take the antiderivative of f prime, they cancel each other out, so I'm just going to be left with f of x. Okay, so that's my function. The next thing that we always do, we evaluate it at 4 and then at 1. So if I plug 4 in here, remember I'm just plugging it in for the x, so I'm going to end up getting f of 4 minus, and then when we plug in 1, I'll get f of 1. Right, so that's just really what we've been doing already. Now we know they told me that this answer is going to equal 7.5. Okay, they also told me that f of 1 is equal to 0.5. So I can go right in here in the problem because they told me that f of 1 is equal to 0.5. So we now have f of 4 minus 0.5 is equal to 7.5. And notice it asks us to find f of 4. We're going to be looking for f of 4. So to solve for this, to get rid of minus 0.5, we'll just add 0.5 to both sides. So we now have just found that f of 4 is equal to 8. Problem solved. Right, the next problem is going to be similar to this, although we're given a picture instead. We want to find f of 0 if you're given that f of 4 is equal to 26, and we're given the graph of f prime. Okay, when they gave me two values, f of 0 and f of 4, and they tell me something about f prime, that's kind of my cue that I'm going to be, and they give me a picture, that's going to be my cue to set up a problem that looks like this. We're going to have an integral sign. Since my two numbers they give me are 0 and 4, I'm going to have my integral from 0 to 4. The function that I'm going to use is this one right here, because that's the one that's given to me. Okay, and then the next thing that I'm going to be doing is actually just like we did in the problem before, I'm going to go ahead and set this problem up. So if I took the antiderivative of f prime, I would end up getting f of x, once again, just like in the last problem, and then I evaluated at 4 and at 0, and then I would end up getting f of 4 minus f of 0. Okay, and it still is equal to 0 and 4 f prime. Okay, then it said to find f of 0, and they told me that f of 4 was equal to 26. So I'm just going to cross that out, and we know that that equals 26. Okay, and the last problem, they told me what this answer on the left side equaled. In this problem, they didn't, but fortunately, they actually gave me a picture. And if we think back to when we first started talking about integrals, we found that when we're given an integral sign, this really just represents the area under the curve from 0 to 4. So I'm just going to go from 0 to 1, 2, 3, 4. This is going to be the area under the curve starting at 0, going to 4. So I've just represented this problem on the left is actually just finding the area under that curve from 0 to 4. So we could actually just find that. They didn't really have to tell me the answer for that side. So to get this, I'm going to call this one A and this one B. To get A, that's a triangle. We'll do 1/2 times the base. It looks like it's going to be 1, 2. It looks like it's about 2.5. So 5/2. And then the height on this 1, 2, 3, looks like it's about 4. Okay, so when I do that, I believe I'm going to get an answer of 5 if I did that right. And then for part B, and actually that would be -5 because it's underneath the x-axis. And then for B, it's going to another triangle, 1/2. The base is going to be 1.5 or 3/2, and then times the height of this one is going to be 1, 2, looks like it's 3. Okay, so for this one, that is actually going to be 9/4. And so -5 plus 9/4. I will have to get a common denominator for this one. And actually, I think just to make this one work easier, I know that 9/4 as a decimal is 2.25. So let's just go ahead and subtract these. -5 plus 2.25 would be negative 2.75. So I just found out that this left side is equal to negative 2.75. Okay, I found out that f of 4 is equal to 26 because they gave that to me. And then I have minus f of 0. I want to find f of 0, so I'm going to subtract 26 from both sides. So I'm going to have negative 28.75, and that's going to equal negative f of 0. And then if I just want f of 0, we'll multiply both sides by negative 1. So we should end up getting f of 0 is equal to positive 28.75. So again, I was able to find my answer, and I was able to use the fundamental theorem of calculus to do that. So hopefully now you can use the fundamental theorem of calculus to solve problems also.